Alrighty, hi guys, welcome to Saturday. What we are looking at today is distance time graphs, and this is the very last thing that we have to cover in the lead up to your exams. So very last thing, we're going to do it today, finish it off Monday, and then we're going to start revising by Thursday. Alrighty, okay, so for distance time graphs, a couple of really important things that you need to know. One of the things that we can calculate from a distance time graph is the speed at which something is going, okay, and we can calculate speed by looking at distance divided by time. So obviously, if we're sketching a distance time graph, the distance and the time is information that we can get from that graph, and we can use that to calculate the speed. From here, there's a couple of other things you need to know about distance time graphs. So distance time graphs, they're always written in terms of increasing distance on the y-axis. So your y-axis is always the distance, and it's always getting bigger. Okay, your distance is increasing as you go up the y-axis, and your x-axis is always time, and again that's increasing. I mean, you can't really decrease time, but it's always increasing going along the x-axis. So you've got increasing distance here, increasing time going in this direction here. Now, what information we can get from a distance time graph is the pattern of movement that something has. Okay, so different types of graphs indicate different types of movement. For example, if we look at this little one here, A, now that has a flat distance versus time. So what we can see is time is increasing. Okay, time is getting bigger and bigger because we're moving along that horizontal line, but the distance doesn't change at all. So this graph, this would indicate that this object or thing or person or whatever it is staying still. Okay, there's no movement, because that graph does not change. Okay, so a horizontal line, I'm just going to write this here. Feel free to write this in if you want, it is quite important information. So a horizontal line, okay, indicates no movement. All right, now here we can see this is this one B. We've got increasing distance with increasing time. Now it's a straight line, so that increasing distance compared to time, that's the same every time. So the gradient, okay, so for a straight line, the gradient of the line gives the speed. Okay, because for example, if we were going, say this was going, 100 kilometers up for every 2 hours that you went across, we could see that would be a speed of 50, because it was 100 divided by 2, remember rise over run, 50 kilometers per hour or something like this. Okay, now in this graph here, our object is getting further and further away because that distance is increasing, it's getting bigger. But if we look at C, where we've got a negative gradient, that's telling us that our object is getting closer. It's going from something that's quite far away, quite a big distance, to back being down at 0, which is quite a small distance. So that's going back to somewhere from there. All right. Now here we have a curved graph. Now the curved graph is telling you that is not moving at a constant speed. The speed starts off quite slowly, but then over time it starts to increase, and we can see that kind of gradient of the graph there, that gets bigger and bigger and bigger, so that tells you the speed is increasing. Most of what we're going to look at for this year involves straight line graphs. Okay, so we don't need to worry too much about the curvy ones, but just so you can see and have a think about it. Now this one here, we can see that we start off with a really steep speed, but then it flattens off. So over time, that speed becomes less and less and less and less. Last one, this one, F. Again, this is a straight line, but it's got a flatter gradient. So this would tell you that this is moving more slowly, this F compared to B, where you've got a steeper gradient. If we look at these ones here, again, you can see this kind of comparison. So here we've got a really fast straight line, and it's going at a constant speed because you've got that constant gradient. The straight line goes up by the same amount every time. The curve graph, this one's getting faster over time. And then this is kind of a very typical distance time graph because it's showing you what different motion is occurring over a period of time. So to start off with, this object has got a steady speed and it's increasing its distance over time. Then it stops and it's actually stationary. So then we've got time changing, but the distance doesn't change. So our object is stationary here. And then it goes back, it returns at that steady speed back to the starting point. Okay, so we're going to look at a quick example with the type of question that you could probably expect. So here is the distance from my house. I want to go to Salisbury, but I'm stopping through Devizes. And so altogether, I'm traveling 60 kilometers away from home, but then I'm returning back to home. And I know I'm going back to home because I go back to 0 here. Okay, so this is home here. And then I arrive back at home at 2 p.m. here. Okay, back at home. All right, now a couple of questions to go with this. What is the speed? So part A, and I actually might just make this... Sorry guys, I think I should just make this a little bit smaller so we can see the questions a bit better. Oh dear, rubbish. Shouldn't have done that. Okay. Lovely. And then home here. Home here. Cool. Easy. Okay. So part A says, what is the speed of the car from home to Devizes? Now to work out the speed, again, speed is distance divided by time. So I want to look at from home to Devizes, how far have I travelled versus how long was I travelling for? So here I can say I started at 9 a.m. I arrived at Devizes at 11. So that is a difference of 2 hours. And speed is always in kilometres per hour. And from home to Devizes, I've travelled a distance of 30 kilometres. So my speed from home to Devizes is 30 divided by 2. So 15 kilometres per hour, right? Extremely slow, but I do drive a Mini, so I guess that kind of makes a bit of sense. So 15 kilometers per hour. Now, the car breaks down in Devizes. This is the second part of my question. How long for? So now I've broken down in Devizes, and I can see that because I'm actually not moving now for a whole hour. So between 11 and 12 o'clock, I'm not moving. I'm staying stationary, and you can see that because of the flat line. So I've broken down in Devizes. How long for? For 1 hour. And then I might even write there 11 a.m. until 12 p.m. Okay, C, what is the speed of the car from Devizes to Salisbury? So now we're looking at the second part where we're increasing. I'm going further away from home. I'm driving from Devizes to Salisbury. Now, in this case, I've gone another 30 kilometers because I've gone from 30 to 60. Okay, so that's 30 kilometers. And I've gone from, in terms of the time, I've done that 30 kilometers between 12 and, so in that half an hour, I've gone, and I'm using 0.5 because one, it's instead of 30 minutes, because you're not dividing by 30, you want to convert it to an hour, and we know that's half an hour, so 0.5 of an hour. So 0.5, 30 divided by 0.5, so my speed equals 30, my distance, divided by my time, half an hour. Now if I go onto my calculator, and I do 30 divided by 0.5, get that? So that's 60. So my speed has actually increased quite a lot after getting my car repaired, and that's now traveling at 60 kilometers per hour. Okay, D. So I'm doing it over here because I'm just running out of room. The car is transported by a recovery vehicle. Okay, so I've broken down again. I'm getting a recovery vehicle from Salisbury all the way back to my house. At what speed is the car transported? So now I've gone from, I'm looking at this negative gradient here because I'm going back home, back to my starting point. So in total, I've travelled 60 kilometres, okay, from that point back home. And again, you can look at that from the graph if you join that along. Okay, that's 60 kilometres. Okay, and my distance, my time that I did that distance in is from 12:30, which is at that tip there, to 2 o'clock. So that's 1.5 5 hours. I've got 1 hour between 1 and 2 o'clock, and then half an hour between 12:30 and 1 o'clock. Okay, so my speed for the recovery vehicle is now 60 divided by 1.5. Sorry about all the notifications that keep coming up as well, by the way. I can't control it. 60 divided by 1.5. Okay, so that's 40 kilometers per hour. So the recovery vehicle is doing a consistent pace of 40 kilometers per hour. Okay, hope that makes sense. I'm going to chuck up some questions for you to do and get those done so I can check them as soon as possible. Thanks very much. Have a nice weekend.